Hi, I'm Jared Pottinger, Education Services Manager for Deskcase, and this is Fundamentals of Lubricant Contamination Control. Now, to understand the value of contamination control, we need to understand why machines fail. As it turns out, machines fail because they wear out. It's not the only reason that machines fail, but most failures are related to wear. And if we look at what causes wear, we find that most wear is related to lubrication, either mechanical wear or corrosion. Turns out most mechanical wear corrosion is really attributable to just one thing, one aspect of lubrication, and that is contamination. Particle contamination and moisture contamination work together or on their own to cause most corrosive wear and certainly most mechanical wear. So if we can control contamination, we can control the rate of wear in our machines. And if we can control the rate of wear, we can extend the life of the machine. And that's really what proactive maintenance is all about. So to control contamination, we need a strategy. We need a plan, we need a process. And that process typically has 3 steps. The first step is to identify how clean or how dry the oil should be. So we can start by establishing target particle counts and target moisture limits for different types of machines. So gearboxes, for example, could get 1 target. Hydraulics would have another. Pumps, paper machines, turbines. Any class or category of equipment could have 1, at least to start, 1 target particle count and 1 target moisture limit. The next step is to identify the things that we can do to actually achieve those targets. So we can basically look at 2 different approaches. We can either exclude contaminants or we can remove contaminants. And in many cases, we actually need to do both. But we should start by looking at ways that we can exclude contaminants because that is the simpler and cheaper way in most cases. And for a lot of machines, that's really the only thing we can do. For some machines, there just isn't a good way to remove contaminants other than just removing the oil itself from those systems. When it comes to exclusion, the good news is that most contamination comes from just 2 places. It comes from the new oil we put in the machine, and it comes from the air that the machine breathes. So to address the new oil issue, conceptually that's easy. In practice it can be challenging, but we need to filter our new oil, and we really need to think about the whole process, how we receive the oil, how we dispense it, how we transfer it, and how we apply it to the machine. There are a number of different products on the market, from dispensing equipment to high quality top-up containers to fittings that are designed to allow us to add oil without needing to use funnels that make that simple to do. The other common source is air that the sump breathes. Well, there are a lot of different breathers on the market that will condition the air that enters the sump when it breathes. So we can exclude both particles and moisture from entering the sump. Now, like I say, for some equipment that's going to be enough, and that's going to be the extent of our strategy. But for others, especially things like hydraulics and circulating systems, we also need to improve our ability to remove contaminants. So we should start by looking at filter performance. What's the pore size of the filter? What's the beta rating or the capture efficiency? How good is the filter that's in place, and can we upgrade that? Many times we can. If that's not enough, we can look at additional ways to filter the oil, namely offline filtration, kidney loop systems that are either permanently installed or portable systems, which we sometimes refer to as filter carts. A filter cart is one of the most versatile and one of the most useful tools that we can have in a precision lubrication program. We can use it to decontaminate systems on demand. We can use it to decontaminate systems permanently, ongoing, or we can use it to transfer lubricants and to filter stored lubricants. A lot of different uses for portable filtration equipment. If we have moisture concerns, we can remove that too. We can use water stripping filters with that same filtration equipment. We can use vacuum dehydrators or centrifuges or coalescing filters. But no matter what we employ, we need to be able to verify that these things work. And that's the 3rd step. The 3rd step is to measure the contamination in the oil to see if we're being effective. For particle counts, that means good sampling. We have to take good samples so that we get valid particle counts, but we also want to have repeatable, consistent data so that we can make sure that we're consistently meeting those targets. For water, it means doing the right test. We need to make sure that the tests we're doing for moisture are sensitive enough to measure water below our target moisture limits. So remember these 3 steps: set targets, Identify measures to control contamination and effectively measure contamination levels. If you do these things, you will control contamination. If you do that, you will control the rate of wear in the machines and you will extend the life of those machines. And again, that's what proactive maintenance is all about. I'm Jared Pottinger for Deskcase, and this has been Fundamentals of Lubricant Contamination Control.